clearly taking on a project like this is significant, and it always goes better when you have good plans, and we've always operated with a long-range plan authored by our golf course architect Rick Jacobson. This is our third one. They last about 10 years. They are living documents. They're not necessarily plans written in stone, but they are plans that help guide us from phase to phase, so we end up at the same end game. This document has got a lot of depth to it, a lot of detail, a lot of infrastructure information about our existing greens and the challenges they may have, our data on our NTEP trials that we host 3 NTEP trials, a very detailed soil map, hole by hole. That's a wonderful report, has a lot of detail, greens, tees, and fairways. And then there's other sections that have the USGA report, our annual service that we subscribe to, the half-day visit, and have them feed into the information, drainage plans for each hole, all the fairways. And then the architect took a lot of time to research old images of the golf course back when it was built in 1924 and try to get a feel for what the golf course looked like when it was constructed in the first early years. We also have a detailed slope analysis of every green. Every green was scanned with great detail, and he uses this as a guide for pinnable placements, pinnable areas on the greens. So you can see the red kind of indicates a slope of 4% or more. With green speeds today, you couldn't really use those as pinnable places. So we're using a guide around 2.5 to 3% as the maximum slope around a pin placement. And then from that, Rick did simple line drawings of each green. So every hole, every green, every aspect from drainage to irrigation to turf type, soil types are in this book that helps get us the proper information that the decision makers could digest and help us move forward as a facility to maintain its competitiveness, reduce the risk, and keep meeting member and guest satisfaction. August 8, 2016, pretty hot weekend. We got that 6-inch flooding rain that kind of hurt us a little while back. It flooded our root system, lost a lot of roots. But we're still doing what we can to keep these greens firm and fast, and that means hand watering throughout the day, several times a day. But you can see here on number 6 how the POA is just modeling out. You can see the yellowness. You can kind of see the dark color here, this wilting. It's July 7, 2017, and we're well into our renovation project. We're saving 9 and 18 in the practice putting green for last, so these are going to stay here for another couple of weeks. We really haven't been maintaining them, mowing them occasionally, but you can just see the varying degrees of plant genetics here. You have a lot of poania that's either dead or dying from the lack of water. You can see it's going to seed again. Even in July, we got a heavy seed crop coming. Usually a sign of stress. And then you can see some creeping bentgrass. Here's a pretty good patch of bent here, doing fine. All different types of textures, growth rates, growth habits. So you can imagine trying to maintain this, all these different requirements of all these different grasses on one green, how much of a nightmare it would be. Which ones do you tailor to? The weakest one, the strongest one, and then and for playability, you can see the different growth rates, different textures. Just a real challenge to have this extent of diversity on a putting green and trying to maintain it and supply consistent, even playing conditions. It's June 8th, 15, and I have here some pieces of sod now, so these have not been mowed all spring, so several months of growth on these chunks of sod here. And what you'll see here is all the different genotypes or biotypes of the grasses that exist. This would be very similar to our greens at North Shore if we were to allow them to grow out. You got the longer, more coarser grass here being the bentgrass. You got this real fine pygmy poa, they call it, or the perennial biotypes. Some people nickname this the Oakmont bentgrass. Look how fine and tight and dwarf it is. It almost looks like moss. Again, this has not been mowed all spring. And here we're in the first week of June. Then you got mostly this annual biotype of Poania. And what I want to point out here is a couple things. First of all, in the spring of the year when it wants to flower, you can see it shoots mostly the stalk with the seeds up. So it's impossible to get smooth, fast, true putting surfaces when the Poania is doing this thing here of pushing up all these seeds. And it's also hard to get it firm because you got all this biomass being developed on the surface that's going to cush and make the surface soft. So the other thing is that when the poa puts so much effort, so much energy into the seed, it's doing so compromising its carbohydrate reserves. In other words, this poa here that's not producing any seed is going to be much hardier come summertime when summer stress kicks in than this Poania, because all those carbohydrates and energy went into producing this seed instead of roots or just storing the carbohydrates for bridging the times of stress. Something else I want to point out, you can see this chunk of sod here, from this point over is mostly the bentgrass, from this part over is primarily Poania. You can see just the plants that wants to root. Look at all the white roots that's primarily underneath the bentgrass. Very little white roots that's underneath the Poania. And this is in a greenhouse setting, perfect situation, no stress, not even being mowed. So bentgrass has obviously a much hardier type species reputation behind it, much hardier winter hardiness, much more tolerant of drought and summer stress. However, you can see it's a very coarse grass compared to the Poania. So the plant breeders have done a wonderful job in still managing a good disease suppressive bentgrass that can withstand these different stresses that I mentioned, but grow more like this Poania, very fine textured and very dense, something like Pure Distinction. There's about a half a dozen of them that grow similar to this that allows a high quality playing condition, playing surface, but a far more sustainable as it pertains to agronomics and inputs and water that's necessary to make the bent versus the poa grow. So after Rick marked all the lines, meaning the area disturbance, the fairway lines, how they're going to tie in, and the green lines, you can see, for example, this is the new fairway line coming in. We're harvesting this bluegrass here and transplanting it over to 5. Then we're going to take this approach side here and bring it to this area here. The guys then start stripping the sod while the other crew starts to remove the sand, the old bunker sand. It's really kind of an odd feeling though, seeing a sod cutter on your greens after spending so much time and effort keeping these things going. But the improvement is going to be just so much better. Then here's there's the new putting surface. You can see the white line quite a bit larger. And then this is the area of disturbance that will probably have the bent grass then come over the top of this rise. Most of this will probably be bent at fairway height. And this will be a runoff area here. You can see the white line. This definitely represents fairway turf to the left. It'll be rough to the right. Once the area is stripped of sod, then Rick, the architect, draws his topo lines and puts in a few stakes. So you can see, for example, this is one grade stake here, with this red line being one topo line. And you can kind of get a feel then for the type of grades that's going to occur. He makes notes. For example, this orange line with the X, that indicates a slight modification of the existing grades. He wants to fill that in slightly. Just a little bit of a hollow there. Always making sure surface drainage works well. He's bringing the front of this green up slightly, and but again, generally the same flavor of a putting surface, just with tweaks. The green itself on this one, number 3, is slightly larger, but not too much. It's not a whole lot of room to bring it out. But you can kind of get a feel for how we're pre-constructing the grade first. We're going to go to 8, and I'll show you what I mean, possibly 1. This is staked out and measured, and then the guy's going to come and, for example, fill this little hollow up the way Rick wants it, and then get it finalized in this rough format first before they start coring down. So they're pre-constructing the greens putting surface before they actually do the coring, which is really nice. It allows me to also footnote where the variable depth's going to go, where the ridge lines are pretty significant, where we're going to take less of a cut going down by up to no more than 3 inches, and if there's a pretty good swale, we're going to deepen that no more than 3 inches to keep the surface moisture a little more consistent with the undulations that occur in the perched water table that these USGA style ridge zones have. Michigan State University has done some really good research on the variable depth. So the concept's pretty simple. That the perched water table that these USGA ridge zones, these profiles develop, when flat and level, the moisture throughout that ridge zone is consistent in the sense that the surface dries out equally across the entire top. So the variable depth, what it tries to do is address that, and obviously putting greens have a fair amount of undulations generally, this one being 1. And the concept here, you can see I painted out this red dashed line with the big 14. So this little ridge line down the center of this green is going to be dug to only 14 inches deep. 4 inches of that will be the pea gravel. So basically it's going to have 10 inches of ridge zone mix on top of the 4-inch pea gravel. And as you come down, it'll just slowly taper to your traditional 12-inch depth. You know, this is all based on the moisture release curve of the sand and the peat that we're using, which is basically a 90-10 Dakota Reed Sedge peat. And then whenever there's a valley, deepening it. So where those gentlemen are standing now as they're getting ready here in the morning to get their work done, that's going to be dug slightly deeper, 2 inches deeper. So then that moisture that's being perched down just above the pea gravel will be just a little bit further away from that surface. So at the end of the day, what this will do is help maintain a more level, or consistent, I should say, surface moisture. So what's going on here, after the green's all laid out and pre-constructed the grades basically, and then all the grade stakes installed on all the grade shots here on a grid pattern, so the green is documented exactly the way we want it now as we pre-constructed it. Then they take off the top several inches here. That's basically our sand top dress, and you can see just underneath our sand is this organic muck that's caused us the trouble when things got really wet. Soil moistures got warm and rain events occurred. That organic layer down there that these greens were built from just held too much water. So we were always on the edge during hot, wet weather, trying to punch holes and do things agronomically to keep the grass going alive. But at any rate, so this is the general layout, this is the concept, and then once they peel off this top few inches, then they're going to go down the balance of it, because we're going to save this material as topsoil and use it to feather in the shoulders here, the aprons, and the runoff areas. So we're utilizing that as kind of like our 7-2-1 mix if you were to buy something like that. And then the second cut gets hauled off to these areas like seen in the background there. We have these naturalized areas we're developing, and the sand from the bunkers is used to fold on top of this organic stuff so we can grow fescue successfully in that sandy mix as we cap it. So this phase of the project, the green has obviously been cored out. This one had a little bit of a variable depth assigned to it along that ridge line back there and along that low area in the front. Just varied the depth 2 inches in both areas. You can see the grade stakes have been preserved. So after the little mini backhoe came in and did the excavation, then they put a skid steer down in here and kind of glazed it over and fine-tuned it. And so this is our subgrade now that's ready to be trenched and have the drainage installed. You can see it's really interesting, the layers here. You can see the black muck just above the clay base here. You can see the clay, so we have a good solid footing here. What I want to point out is this real dark band you see around the whole green cavity. That's that organic muck layer. So here's a real good example. Here's our sandy top dressing. Some of it's already been removed, but this area here is what create us a lot of trouble. And then underneath that's really heavy clay. So heavy clay that doesn't let water pass through readily at all. So at any rate, we have a clay base here that will definitely hold water, and then we have this spongy like peat that the greens were built out of back in the early 20s. And it's perhaps pretty good garden soil amendment like material, but for putting green use it's not good at all. It holds way too much water when it gets wet from natural rain events. It also lacks porosity for good air, and bent grass would not do well in that environment at all. Poania can possibly tolerate it to some level, but here you can see the clay, the type of clay I'm talking about. And then here you can see the backfilled trench of the XGD. We tried the XGD, you can see all the pipe here that was removed. So here's the remnants of one. You can see how it was trenched in, backfilled with a sandy mix. So this helped drain our greens pretty well as far as the top horizon goes. So with the rain coming down, it would run through this sandy profile and eventually find its way into this trench at times. But if this ever got wet, the drain really didn't do much for that. And then on the flip side, when we try to dry the green out, what happens is this sandier mix gets wicked dry with this organic-y material surrounding it. So then you have drying areas that was really problematic. This soil would stay moist, this would dry out, And so basically it was a nightmare trying to manage these greens, having all these different soil types. Here's another naturalized area that we're using to get rid of our fill. That's the old sod, the sod that we didn't salvage and utilize somewhere else. So that's going to be mixed in with the undercut of the greens material. The top cut of the greens material that's really sandy from the sand top dressing is going to be salvaged and used as soil, topsoil. This here is going to commingle with the clay and the organic matter and then topped with the sand, the old bunker sand. So ultimately these will end up being very gentle little raised areas, little kind of, I guess, berms for lack of a better word, and regrassed with fescue. So the taller fescue is going to disguise the slight berming. We really don't want to deface the golf course and have a bunch of, you know, severe berms out here that's out of character.
Okay, so we're looking at some of these green complexes as we move forward, and we're looking at the fairway collection areas. We're looking at the drainage in those areas, and if it needs inlets or any supplemental drainage to make sure that we don't have these fairway collection areas in low spots and wet areas. So on 15, we've got a swale between the tee on 16 and the back right of 15. And right now we've got good surface drainage, so we could get it off from this point, but there's a slow area in the back that we need to shoot some grades to make sure that we don't have a collection area of water, a water holding pocket.
And what are all these other notes that you went over with other greens?
So these are areas showing fill and cut areas within the putting surface to tie in the features around the green complex, making sure that we've got the proper surface drainage, and also that we have the proper percentage and slopes to provide pin placement locations. So we've expanded the greens, but we want to make sure that we actually are retaining pin placement opportunities in those expansion areas.
So you put down on paper what you need to be done in the field, and Kwai, you go out in the field and put down what's on paper in the field.
Yes, sir.
Looks good. So you can see when you are dedicated to only one outlet, it becomes a very deep trench depending on the green design. This one here ended up being very deep. You know, this would have been a little more tedious to do with a trencher, but it was important to us that we had only one exit, so when a flush occurred, there was a stronger vacuum associated with it. Plus, with the precision air vacuum extraction, we're dedicated to only one outlet and one penetration in the back to force the air into the system. This is the precision air system, and in that larger container is a floating ball, basically, that when it fills with water, the ball floats up and allows the water to pass through and act as a traditional drainage system for the putting green. When there's no water in there, the ball drops to the floor of that canister, and then it can travel back and forth with the air that's being forced in it to kind of seal it off. So the idea is you blow air, the ball rolls over, seals the outlet, and then the air is forced up through the green cavity. The other thing I like about doing it with the mini backhoe is the trench itself is larger. With a trencher you end up with about a 6-inch trench. This is about a foot. So all this gets backfilled with pea gravel, which is wonderful. Adding to the capacity of the drainage. You make sure the slopes are all accurate and the pipe itself is perforated, because we have two piles, one with and one without holes. You want to make sure they don't accidentally grab sticks that don't have holes. Make sure the trench is nice and clean, a slight taper away. We dictated the mini backhoe to make these trenches so it actually has a foot wide trench instead of trenching, which would be about half of that width. So we have a little extra pea gravel down at the bottom of all these trenches to assist in water moving. See, nice firm bottoms, nice glaze to it. So now we're securing each joint with 3 screws, and then we're taping it with that heavy duty Gorilla Tape type stuff. No screws on the bottom, just one on the top, one on either side. We don't want part of a screw to kind of catch on any debris, even though there shouldn't be any. Any old drain tiles that they run into, God knows from what, gets plugged up, so gravel doesn't find its way in there and create a sinkhole later on. Perimeter drain, solid pipe from this point out. So this is a pretty good representation of a nice cavity ready for the pea gravel. So now we have the PC drainage rope. What we decided to do was we stripped the wicking rope away, a section of it away, and exposed the inner coil, and we have that position at the very bottom of the drain pipe. We're not interfering with the integrity whatsoever of the standard drainage system. And for now, the rope is just supported with this stake. They'll backfill this with the pea gravel, have the 4-inch bed on top, and then we'll take the rope and lay it out as you've seen in other pictures. But that's how we decided to install this. So there's no chance of interfering with the integrity of the drain system. This is just an enhancement to help water movement and continue to address the perched water table in pockets, low pockets like this that might have water sitting here for too long. This whole green drains to this area, and this would be the last area to dry out basically. And I think it's a big assumption that when these things flush, that you get a complete thorough flush each time. So if you don't get a complete flush, then this area here will tend to be the wet area and perhaps turn anaerobic. To add to the drainage, we also are not wrapping it with the fabric. You can see the black barrier. From there to there, we're leaving it open. So the natural native soils that are finer than the root zone mix will wick the excess moisture out of the sand as well in this low area of the green. This is what we're doing to all the greens. So here is one of our staging areas of the pea gravel. This is the real fine bird's eye pea gravel that we're going to use on the putting greens. It's as fine of a pea gravel that meets the USGA recommendations I can get. I really didn't want a coarse pea gravel. A finer pea gravel will allow the purging of the perched water table to occur easier than a coarser gravel. So in this phase, we're installing the 4 inches of pea gravel. So they're setting up their little measuring stick to ensure that it's a consistent 4 inches. You can see the drain tile all screwed together, every joint's taped. The barrier here, we kind of created a little dead man, stapling it to the base, wrapping it underneath. So this will be our barrier to keep the wicking action away from the mix. So here you can see some of the grade stakes that are left. So just give them a rough guide as the root zone mix is installed on top of the 4-inch pea gravel. You can see the locator blue wire there, the PC drainage rope down in this low area. You can see where we did not put the barrier in this low area to add to the wicking action to help this area dry up. This is the low area of the green. They rough it in with a skid steer, then they go back by hand and detail it, and then they confirm it with GPS and compare it to how it was built before we started the coring process. All these greens, the surfaces were built before coring by Rick Jacobson, our architect. He was tweaking the grades. They stripped the sod basically, and then used the bunker sand if they had to add any fill to make any of the contour adjustments. Once it was blessed, then it was documented with the grade stakes and with the GPS on paper, and then they cored it. We're getting ready here to put the pre-plan amendments down that we're going to rototill in the 90-10 Dakota Reed sedge. You've got Cool Terra, real clean char, beautiful material. Coconut hulls is the parent material. Permamatrix, this is a probiotic with a little bit of char and a carrier. Milorganite, some chemical-based fertilizer. This one here is the chip humate. We're going to put some chip humate down. It's high in fulvic. Poultry manure. What's that one? Potassium sulfate. That's worm power, or
Sanctuary is microbiotic.
This one's Sanctuary?
That's a Sanctuary 804.
Okay.
This is a Sanctuary 334.
Another Sanctuary probiotics. Is that Milorganite there?
Milorganite.
That's Milorganite. And then this is the Miramichi biochar compost 50/50 material. So this gives you an idea over about a 5,000 square foot green, the type of material we're going to rototill in. Then we're going to follow up with the liquid spray, all targeting to pretty much precondition this clean char. This is a real clean char. So we're trying to inoculate that and precondition it with nutrients. This one here has already kind of gone through that process, being in a 50/50 mix compost biochar. So this is kind of already ready to go. Vetus calibrated the equipment. He converted some of this from volume to weight and found which spreader worked the best. This old-fashioned Lawn Beauty actually worked pretty well with a lot of them because of the agitator it has. We broke down the all the rates. We calibrated it, and I don't know if you can see these. Hopefully you can see these names in this, the chip humate and all the different materials, and we broke it down per green. So this is number 7 green, for example. This is the total amount of material that's going to be needed for that green at 6,200 square feet. Number 1 is 5,500 square feet, and all the materials there. So they're all measured. So here we're applying the biochar, and like everything, we try to calibrate the equipment to force us to go 2 or 3 times. We don't try to apply it all at one time. So this is 1, this is 2 now, and there'll be one more pass. So this gives you a feel for the rate that we're using. It's not a very heavy rate. So we have this, then we have the chip humate, then we have the Miramichi biochar compost, we have the vermi compost, and the this is the Cool Terra char, straight char. Then we're going to apply a bunch of biologicals and some nutrients to pretty much precondition this clean char. The Miramichi char is already, we consider preconditioned, being mixed 50/50 with a quality compost. This is this material here we're trying to get it. It's so humid that we found that we have to have 2 people apply it because it's kind of sticky. This char wants to attract the moisture, which is one of the benefits of it, but it doesn't shrink swell like other materials can when it attracts moisture or absorbs moisture. This does not do that, so it's quality material. When we're done with all these applications, then we'll rototill this all in about 6 inches deep. We did the math, so we knew what the volume was for that 6-inch depth. And this is all being done on top of a 90-10 Dakota Reed sedge peat. So here we're putting the liquid portion of the pre-plan amendments down. It's going to react with the clean Cool Terra char, inoculate the sand, the chip humate, and the biochar with probiotics and fertilizer and acidifiers. And Luis, he's in there with the solid tine aerifier, breaking up the hard pan. As you can see here, this was done already. So this has turned out really nice when it's dry like this. Breaks up all those clay clumps that get deposited on top when we do the trenching. So as soon as he's done, I'm going to fire up this rototiller and till this all in.
Good. Good depth.
I came in with the rototiller, walk behind first. Now Dan is finishing up the center area. I gave him a nice buffer away from the edge. Makes you feel more confident to kind of go through. And now with the McGee rake.
Important step is to be sure the sand's all compacted, no air bubble, no air gaps, all settle it so it gets flooded several times and tracked, the skid steer, and you can see how firm it is getting. And the real critical parts around the edge, so they put a jumping jack compactor around the edge, both inside and outside the cavity. Keeps working it, and he keeps flooding it. So what we're doing here now is we're confirming depth, and both with that probe and electronically with that machine there, the level. And then he kind of gets where it needs to get down to. You can see how that's that little depression represents the depth. And then Kwai comes in with the mini box blade here and details it and feathers it out. So this is kind of like the final phase here. He's generating a little bit of extra mix here, and that extra mix has already got the biochar and the compost in it. So we're going to collect that and hot frog it up to the next green, just to make sure that if we have to add any material, it's already pre-blended with the compost, the biochar, and so on. So it's really coming down to a nice little system here. And this is another one of those detail steps. What we decided to do here is the soil that we salvage from the greens is pretty polluted with a POA seed. So we wrung the green 5 feet with a 5-foot ring of straight greens mix, 90-10 Dakota Reed Sedge mix. It was the base mix that we used for the greens. But then the greens, as you saw, we amended with compost and biochar and rototilled it in. So that's already been done here. So now we dirtied up, if you want to call it that, the clean ring of 90-10 with Miramichi's biochar compost. So now we're working that in by hand, and as Tony's doing that, he's also making sure everything's feathered in nice and smooth, so the transition is seamless from the green to the collar. These corners are always a pain because the equipment can't get in there, so this has all got to be done by hand, these corners. Making sure around sprinkler heads the grade is perfect. Any place that you got to add material, you got to make sure you step on it, compact it well. So the green flags here represents the seam. So Tony's first kind of mixing in the Miramichi. It's only a couple inches thick, the sand that we use the aerifier to commingle with the black native soil. So we found that this is the best tool, this bunker rake, because it's got a nice straight edge, the teeth are the right depth, and it really works the material well. So then Tony, after mixing it, he'll come back now and make sure that the seam is nice and perfect, kind of like how we got it here. So it just takes time, it's a little tedious, but the better job you do in this step, the more friendly it's going to be to mow this green as these mowing heights get tighter and tighter. I'm really trying my best not to need a whole lot of top dressing to take out these imperfections. I'm trying to do it all first and not rely on that sand top dressing. Okay, this is like the 4th time now we're checking depths, detailing. These white flags represents the slight adjustment that's needed to get the grades right. So you use the little box blade that collects material from, like you just put it down there. So he's making a little bit of a hollow, and now he's depositing it up there, and then the drag mat helps smooth it out. So it takes a delicate touch with that machine to do that. And he keeps going back, confirming depths with the probe. So it's tedious. Honestly, it takes close to a day, 6 to 8 hours to tie this all in. Now you see he's got a little stopper there. Can't see with his foot. There we go. So he's got it almost perfect there. At any rate, the guys are sodding. Better billy bunker treatments applied. Got to detail the edge. Again, these white flags represent a little bit of a rise. This needs to kind of be emphasized a little bit more. It's coming along, but this is where the fine details count. We're amending the walks. This green here really only gets access from one direction with the lake being there, so everyone either walks onto the green where Luis is at there, or where Tony's at here, or over in this area. And so Kenny's applying some vermicompost to the sand there before they sod it. And we put a lot of compost and a little bit of sand over here too in this throat. Try to reduce the compaction potential and amend the soil so the turf grows aggressively in that high traffic area. So I had to fix this little corner here. You can see how it wants to sweep up. You got to avoid any kind of cupping, otherwise the edge of the moors will gouge into it when you mow it at lower heights. So the best thing to use, I found, is the straight edge behind a bunker rake, the Accuform. And you make sure that when you drag that across, paralleling the collar line, that there's no gap in the sand that's building up in front of the straight edge of the rake. Then you follow behind with a tennis court broom like this, hard true tennis court broom, and this is how you get a real nice fine finish on it. You go one direction, then you turn around and you go the other direction. This really does a nice job feathering it all in. It's just a simple bristle broom that you drag. So we pre-blended 3 bentgrass seeds, 007, flagstick, and Mackenzie, equal parts. And then Tony's hand blending some carrier that are really probiotics, things like actinovate, which is a streptomyces, and some permamatrix. We're using this like some people use malorganite, which this is a whole nother slew of probiotics, mycorrhizas and trichoderma and bacillus, pseudomonas. So that's what we're using as a carrier. And then we calibrated the spreader to go 2 times seeding to give you a total of 1.5 pounds of seed per 1,000. Tony's putting the pre-plant fertilizer down, the drop spreader. He's doing that in 2 directions just to make sure we got a good even distribution. And then he actually rakes it in with just a leaf rake attachment on the Sand Pro. Just basically a scratching in. And then the seeding process is similar in the sense that he uses a drop spreader like he's doing now and goes 2 directions with the bentgrass seed that's got a carrier mixed in it that's actually a probiotic material. It's got a bunch of microbes, a little biochar. We selected that over Milorganite, and then he doesn't scratch the seed in, but he dimples it in with the Sand Pro and the knobbies. Works wonderful. As long as we go straight lines with the machine. And then we water. Fence off the area, make sure people don't go on it. So now you track in the seed with the Sand Pro. We picked our Sand Pro with the newest tires. And you can see the nice dimpling it creates. So it does a wonderful job kind of trapping humidity and pushing the seed down. Prevent a little bit of erosion with the texture. Creates little humid pockets. It just really works out really well. I don't know who thought of this originally, but it seems to be like the standard trick now. So Felix will track the entire green surface, and we finally get to the point where we start throwing sprinklers on. Try to grow it in. Really weird growing grass on mostly sand, but it works. It's just you got to put 1 to 2 rotations per head. On days like today, low humidity, probably every like 50 minutes. You can't wait quite an hour. And do nothing at night. No irrigation at night. You cannot take a chance of a head sticking on or anything. So it's all during the daylight hours while you're here watching it. And in about 5 days, we should see a green fuzz on this. So this is what a green looks like after 5 days of seeding. You can see the slightest little dimples where the grass plants are taking advantage of the little microclimate left behind from the Sand Pro tires, the little knobby tires. You can kind of see the little waffle-like pattern. It's a beautiful thing. Whoever thought of that, it's wonderful. So we're going to give this green another day or 2, and then we'll roll it. Try to start taking out some of these imperfections, and just lightly roll it by hand, the walk roller, and just keep it moist. Now we can start backing off on the water. We were doing basically 2 spins every 45 minutes, depending on the day, the temperature, and the humidity and the wind. And then after about 5 days of that, you see this, and you can start backing off a little bit. Not so much on the interval, but on the amount. Do 1 spin. You rarely can take it past an hour. Normally you're putting some kind of water down within an hour here. That's been our experience with the ridge zone mix we're using and the type of weather we've been getting. So this is 12 days old. We're going to roll it for the first time and mow it. You can see all the little waffle marks here from the dimpling. A couple weeds growing. But beautiful take, beautiful stand of turf for less than 2 weeks old. Looks really good. Just using an old piece of carpet for now as a turning board. It's really tedious. This is the first mowing. Set at 175, the Toro Flex. Sand's just a little sticky, but so we have this little top dresser. It's lightweight. It's just perfect for these new greens. The other thing it has a little attachment that they designed to put seed in. If you wanted to top dress say with compost, and add seed in as an overseeding. But what we're doing is we're adding this material here that we also have as a pre-plant. It has a whole list of microorganisms that are really beneficial for plant and soil health. So we add that in with the sand top dressing. This box here feeds it. So as the conveyor belt feeds the sand to the twin spinners, it also feeds the amendment. We're going to use this for vermicompost and other materials that we want to add to the sand at a later date. Right now we're still kind of in growing mode, so we're adding materials that help with the soil performance over time. Eventually we're going to shift sand top dress a lot less and add material that is responsible for adding porosity, mainly air space. The organic matter that the plant's going to generate will have a high enough CEC and water holding capacity that we really don't want to add any more of that to it. We want to add something that actually adds pore space that air will take advantage of, not nutrients and water. So it's kind of a dynamic system. You build it with certain properties and then you maintain it with other properties based on the impacts of the plant. So you can see it gives it a nice top dressing. We'll drag this lightly in now and start filling these holes as our first top dressing. And we're going to mold this at 1/8 of an inch and just keep working it. There's different ways to work sand top dressing in, but there's one method that I call a maintenance method where you use a brush. It's pretty gentle and it's does a good job working the sand in, but this method here is a little bit more aggressive with this steel mat. And this one here I prefer to do whenever we have a chance because it literally grades with the steel mesh. The sand is actually deposited in low spots and taken off in high spots, so that this method here really does do a better job in filling ball marks and imperfections. If you were to use a brush, the brush literally kicks the sand out of those slight depressions. It's pretty nondescript, and this here gives a much truer surface when you're done, but it is a little harder on the plant because it's so abrasive. We try to do it just one time for that reason. You can see how the sand bounces in there. Well, it's September 21st. Greens were seeded about 5 weeks ago now. And we've been mowing them. We already got them down to 1/8 of an inch with the Toro 1000s. You can see Glenn was just freshening up. The mechanic goes around and checks the mowers continuously, and then after a mower gets 2 greens mowed, it's then brought in the shop for sharpening. So no more mows more than 2 greens to make sure that blade stays good and sharp. You can see we got a good stand, pretty consistent. I took a core out and washed it, and you can see this is the extent of our roots. There's already a mat layer developing there, and you can see the biochar kind of clinging onto the roots, kind of interesting there. There's a good 5 inches of roots, I'd say, nice healthy mass. And this turf is kind of starting to net. We top dressed it last week, so we're now mowing them with the catcher. At first we weren't using a catcher. We're still mowing the collar at the same height as the green. We're treating the collar as though it's part of the green, but basically there's a 5-foot wide area right here that's built outside of the cavity. I'm sure you can see it right about here. You can see this line. So there's several inches of the root zone mix on top of our native soil here, and the USGA root zone is 5 feet in from there. So we'll convert that to collar later next year. We're going to mow it all at this tight height. We're going to fertilize these today. We had a good rain finally after a couple months of construction, and of no rain, and so we got a good rain that flushed these. We have soil moisture sensors over on 3 of them. One at the very bottom of the root zone, kind of representing the reservoir of the water that is being perched on top of the pea gravel layer, and then we have another sensor real close to the surface, and then another one in the middle. And each sensor from Toro has a pair, so you have basically 6 areas being tracked in soil moisture, temperature, and salinity. And it's just interesting to see how after a rain event they all go to dry, so the flushing mechanism is definitely working. The approaches, we grew these for a while to let the POA germinate, then we killed it off, and then we seeded these. These are just a little over a week old, and we mulched it over with the Profile product, and it really popped nicely. We're going to fertilize these as well, and we mowed all these earlier this week, one time only. So we're going to fertilize and continue to mow. And the only thing I would say about the mulch, it's a little tedious, is the plant itself kind of wants to get hung up in this puffy material, so it's a little tricky mowing them until that plant anchors down really well. We have been using turning boards. We still have them, so in areas that they can't get off into the bluegrass, they still use the turning boards to try to minimize any bruising around the outside of the green with the mowing. So it's all coming together really well. We heavily verticut the fairways and overseeded them, so we're trying to get more creeping bentgrass in the fairways and have this seam here be more graceful where we seeded it all. So we overseeded the fairways with 007, and we should get a pretty good take with that as well.